All right, well, hello everybody. So today we're going to be doing the Unit 5 review part 2. This is in preparation for your free response portion of your exam, which you will take on Pear Deck as well. So we're going to set it up pretty much the same way, that way there's no confusion and no issues here. So let's go ahead and get started. So what's going to happen is you're going to be given some type of data table as such. You know, this is your X and your Y. And you want to put this data into Desmos. Well, when we do that, we're going to set it up as y1 squiggle ax1 to the power of b. And that equation is here. Okay? You want to be sure that you set this up as x1 and y1 in the data table. And you put all your data points, and you can see here what happens. Well, we end up getting that A is equal to 0.327. B in this case would be 0.490. And the question is saying, use the regression feature of your calculator to find the square root function that best fits the data. Round all values to 3 decimal places. That's why I went to 3 decimal places here. And so then our equation would end up being, when we plug it into y equals ax to the power of b, we just simply plug in for a, which is 0.327x to the power of b, which is 0.490. And so for this first part, this is what we're getting. For the second part, for part B, it says, is the regression a good fit? Well, we need to look at r squared. R squared is up here under statistics. So we see that r squared is equal to 0.999. So it's asking us, is it a good fit? You have to say yes or no. In this case, it is yes, because r squared is equal to 0.999, which is close to 1. And this would be your answer for B. Okay? And this is how you would do parts A and B, which you can get a lot of points on the free response portion for. Okay, but there's going to be more to it. So let's go ahead and explore that, because I know A and B you guys are pretty solid at. So in this part, guys, it's saying to explain how you can further support your answer to part B using one of your data points. Well, we know one of the data points is at 10, 1. So how do we support our answer? Well, we take the equation that we made, right, which was y equals 0.490. Nope, that is incorrect. Let's fix that up. It's actually 0.327 x to the power of 0.490. And we can plug in these points because we know this is x and y. And you could take any point you want, but I took 10 and 1 because I figured that was a nice data point. Okay, nice whole numbers there. So what you do is you just plug in those values. So we're going to plug in 1 for y equals 0.327 to the power. We're going to take 10 to the power of 0.490. Okay? And so what happens here is you then want to start solving this. And so when we do this, we're going to say that 1 equals 0.327. And let's do 10. Okay? And we're going to raise him to the power of 0.5, which is really just kind of like taking the square root of 10. Okay, which is roughly 3.16. Okay, this is close to it. Then when we multiply that with 0.327, we get that 1 equals 1.03, which is really close. So on part C, again, what we're doing is we're taking a data point from the table, and we just plug it into the equation of A, right? What we got for A. And you're just checking it. You're just proving it. Okay? It's not going to be exact, but it's going to be really, really close. Okay? All right, let's go ahead and move on to the next part, part D. So part D says, write and solve the equation to find the time when the length is 20 inches. So in other words, our input is now 20 inches. So our x value equals 20. So we take the equation y equals, okay, ax to the power of b, which we know y is equal to 0.327x to the power of 0.49. Okay, and we're going to plug 20 in for x. So when we do that, we get y equals 0.327 20 to the power of 0.49. So then let's go ahead and do that together. So we'll do this part first. And it's y equals 0.327, and then 20 to the power of 0.49 is roughly 4.47. And then when we multiply that by 0.327, we get that y equals 1.46. So this is our time. So again, we take the same equation. This is from part A, and we're putting that into this part for D. We're given an x, and we're solving for y. All right. Let's go ahead and move on to the next one. And so for part E here, it's asking if our answer is reasonable. Okay? And they want us to use data points. Well, we just got that the data point when x is 20, we got that y is 1.46. Okay? So we have data points on that table, one of them being 18, 1.35. And why did I pick this one? Well, this one is right before the 20. So then when I put the 20 here, okay, I know that we have 20, 1.46. And my next point on that data table was at 22, 1.5. So check it. 18, 20, 22, this is right in the middle. And then 1.35, 1.46, 1.5, well, this is also in the middle. So this works. So 20, we can say 20, 1.46 is a good approximation. And so what you want to show is that you want to show that it fits right between the two data points. Okay? All right, guys. So I just walked you through parts A, B, C, D, and E. A and B are good ways of getting some easy points. C, D, and E all work off that first equation. So you want to make sure that you get that equation correct in A. Take this and use this and apply it to the next set of questions that you have. Okay, thank you guys. Reach out to me if you have any questions, and I'll see you in a bit.